Great to see everyone from all around the world joining us here today. This is an exciting topic. It's evolving, and you might notice that the title changed a bit since what Nikki shared. I think we did update the web page, and we are now both of us are presenting. This is a rapidly evolving field, so things keep changing by the day, essentially. So let me get started, and let me see when I. Oh, so you might or might not know that the Oracle database platform is what we refer to as a converged database platform. In other words, that means you can do work with many different data types and many different workloads all in the same database. Like way back, I don't know, 20, 25 years ago, Oracle was just a relational database. But since then, it has evolved tremendously as the needs of applications has grown. It has evolved tremendously to support many different data types. So today, if you're working with graph, and you're working with vector, and then you need to work with location data, you don't need to bring in a whole new database. You can just, in the same database, perhaps by virtue of just adding a new SQL statement, you can access this new data type. Okay, or if you're using Python, you can use some Python drivers for connecting to the database and then easily start working with a new data type. In this session, we are focused on the ways graph queries can combine and complement vector search, combine with vectors and complement vector search. So that's what we'll focus on. But the cloud account that you're all signing up for, that gives you the ability to work with all of these different data types all in one database. So I'll start off with a RAG recap because probably most of you here know what RAG is, Retrieval-Augmented Generation, but I don't want to assume anything, so let me start with a recap. So we all know, of course, as of the last 3 years, when you want to ask a generative AI service a question, you just send it a query and it gives you an answer based on all that it has learned from information that it has access to. So if you say, find me a popular movie, it'll find you a popular movie. Now, if you want to be specific about what you're asking so that the question relates to what you might have in your own database, in your own enterprise, in the company you're working for, something that's private and not publicly accessible to the generative AI service, that's when you have this RAG or Retrieval-Augmented Generation. So when a user query needs to refer to information that's private within a database or some kind of data store, and then retrieve that context and provide this enhanced context to the generative AI service, so the response from GenAI can include the context that you have in your private data. So you have this user query, natural language, find me a popular movie that Melly might like. And Melly is a customer, so her preferences are going to be stored in a private database. You can encode that as a vector, use that vector to find matches within your database that are relevant to this question, then take that enhanced context and send it to GenAI and get back an answer. That is essentially Retrieval-Augmented Generation. What we want to see here today is how graphs can combine to make this even more interesting or help you provide even more context. So before going into graphs, I just wanted to say one thing about the Oracle Database Service, where we have something called RAG in a box. So you have all of these different steps when it comes to RAG. That is, you need to create the vectors, store the vectors in the database, and when the prompt comes in, have the prompt go in and retrieve the top matches and send the query to the GenAI service. You can do all of that in basically by doing some basic setup, and then you can just ask a user query like we have here. It just says, narrate a strategy for promoting popular movies. And as long as you've done the setup, all of this will be done behind the scenes. Taking any documents you have, creating vectors from it, matching with the user query, all of that will be done behind the scenes. So you can hide all of that makes your application development simple. You can just focus on your user query. So I think this might have been covered in an earlier session. So we will now go to the core part of this session, which is using graphs to enhance context. When you're working with RAG or essentially with vector search or any kind of technology related to AI. So let's start with what a graph is. It's not a bar graph or a line graph or a pie chart. That's not what we mean by a graph. When we say graph, we mean a data model that kind of captures how data is connected. So you're all familiar with, I'm sure, with the rows and column organization of data, either as an Excel spreadsheet or as relation tables in the database. You have rows and columns, and each row refers to one entity. Like if you took all of us attending this call together, we could all be just rows in an Excel spreadsheet. But you could take the same data and look at it differently in the terms of how these entities are connected to each other. For example, I'm connected to Rahul, who's a colleague. I'm connected to Nikki, who's a colleague. I'm perhaps connected to Bill through Nikki because I work with Nikki. Nikki works with Bill to set up this series. So we can see here that by making connections explicit, we get more information about these entities instead of just looking at them as rows in a spreadsheet. So you have anything, any data set that has entities. It could be attendees at the event like this. It could be customers. It could be products. It could be bank accounts. All of these are entities, and they're connected by some relationship, which is they either know each other, or there's a money transfer from one bank account to another, and so on. So that's basically a graph model. And the most intuitive or logical example of a graph model is social media data. So if you go on LinkedIn and you say, I want to connect to someone, LinkedIn will typically tell you that you are 2 hops away or 3 hops away from this person. So some kind of graph query is being run behind the scenes. So here you can see that Ethan and Amelia are connected to each other because Ethan knows Alex, Alex knows Henry, Henry knows Amelia. So this is the kind of thing that graphs are really good at, navigating these relationships, going from one entity to another, and so on. And also, we'll see that some other social media examples are very intuitive for graphs, but the other data sets, because any data set has relationships. So it's really, you can model almost any data set as a graph, and then use that to ask different questions of your data, and use that to enhance your AI application and so on, as we will see. One example is manufacturing. Product dependencies, like a phone is made up of 1,000 parts, all kinds of complex dependencies between the components and subcomponents that make up this phone. All of that can be modeled as a graph. And then financial transactions, which is a very popular use case for graphs, because when you model as your bank accounts as the entities or nodes in a graph, and then every time the relationship between these bank accounts is when every time there's a money transfer between accounts, you can start following the flow of money when you query this graph. So as long as you have the syntax to query this graph, just like you have the syntax to query a database. If you have the syntax to query this graph, you can start asking questions like, what are the different patterns? Is money moving around in a cycle, which might mean tax evasion and so on. So either money flow or data flow or relationships flowing through this graph, all of this graphs are really good at explaining or uncovering things like relationships like that. So what we have in the Oracle database, and you'll see the call to action section, we'll have a lot of live labs that you can go through. You can either use that with the account you're setting up, or some of the live labs have their own, what we call a green button option. You can just provision an instance for running the lab. What you'll see in the lab is, one of the things you'll see is we have tried to make it easy to create a graph from your data. And data is almost often, your business data will often be in relational tables. So in the spirit of the converged database, we want to make it really easy to create a graph from data in tables. So we have SQL syntax for SQL, that's language that we have used to query the database and now has new syntax for querying graphs. You can use SQL to create a graph view on relation tables. So you take the data and tables and this kind of highlight or make explicit the relationships and data I was talking about. So that, as I was saying earlier with the Converse database, so tables and graphs and location data and all of those can coexist together. So it's really easy to create a graph. In the labs, you will see how easy it is. We're not going into that in this session, but it's really easy to create a graph. So I want to talk a little bit about knowledge graphs now. So knowledge graphs is a very, I think it's a term used now in the AI context. I mean, everybody wants to use the word knowledge. So at some level, knowledge graphs can be used to represent any type of graph, and the financial transactions graph, the manufacturing graph, the social network graph. A slightly narrower definition would be is you're looking at entities and concepts in your data, and that could be a knowledge graph which kind of captures a particular domain. So in this case, maybe it's a question of employees and what events they're attending where. That's what I'm trying to capture in this graph. So Melly maybe attends the Analytics and Data Summit conference, which is held annually at Redwood Shores in California. And other colleague, Joe, is also in Redwood Shores, California, but to attend a different musical event. So you can see here that Joe and Melliyal are connected by the fact that they're both in Redwood Shores at the same time, but attending different events. So, and we can keep building this graph. Let's say Melly has colleagues, Denise and Kareem, and they're also at the same event. So you can see here that this graph is now kind of more tightly connected to each other than it is to this part of the graph. So Joe is kind of separate because he's not attending this event, he's attending a musical event. There's some connection here, but not a tight connection, whereas Kareem and Denise and Melly are tightly connected to each other because they're attending the same event and also their colleagues. So this is the kind of pattern that graphs kind of help you that help you find out easily. I mean, it's not that you can't find these out with tables or Excel spreadsheets, but graphs kind of immediately highlight. There's a visual component that helps you immediately hone in on, okay, this is a tightly connected set of entities. And you can keep building out this graph. Melly is presented at our conference, and Melly's location is different from your colleagues, but Melly and Denise are in one location, but Kareem is in another location. So we're looking at similarity of nodes. Melly and Denise might be the most similar. They're both colleagues. They're both located in the same place. And they're both at the same conference. But then there are some differences when it comes to someone like Kareem and so on. So you keep building out your graph, and then you can also have these concepts such as both the Machine Learning Conference and the Analytics and Data Summit Conference fall under the broad umbrella of AI ML interests. So you can have these kind of broader concepts and then kind of sub-concepts that, again, graphs are really good at representing that as well. So when it comes to graphs, like just to recap quickly, you can have social networks of graphs, financial transactions can be represented as a graph. Any other concept you have in your data, like we're looking at this here, can be represented as a graph. So with that background on graphs, and by the way, if you have questions, please do post. I have my colleagues also responding to chats. If something was not clear, please post a question and somebody will answer the question. So now we'll go with graph RAG and how graphs can be added to Retrieval-Augmented Generation and basically added to vector search. So what happens when you're adding graph is, so we saw that in Retrieval-Augmented Generation, the user query is enhanced with context retrieved from the database. Now to that context, we want to add graph search because graphs are really good at traversing relationships, either traversing the flow of money or traversing how people are connected to each other. It's really good at traversing the flow of relationships. So we can have this vector search, complement that with graph search to have even better context when you are enhancing this prompt that you're setting to GenAI. So in the rest of the session, we will go through 3 examples. In the first 2 examples, we'll be using SQL, and the very first example is just a simple combination of graph queries with vector search, all in the same database. Then example 2 and 3, we'll see how graphs can be used to better search documents, how graphs can enhance that, and you can have a graph-directed search to perhaps reduce hallucinations, reduce wrong answers, and so on. So the first example, the really simple example, is this. I just want to combine graph search with vector search. So I want to combine like social network traversal with a vector search of movie descriptions, because I have this data set here where I have custom information on customers watching movies, and I want to use this to basically learn how to make good recommendations for a customers or a set of customers in terms of what movie they want to watch. So I'm going to use a graph to represent the relationships between customers, and I'm going to use vector search to search through the summary column that we have for the movie table. The summary column has a description of the movie. So the vector search is going to go through the summary column and find relevant movies for a particular set of customers that I'll identify through social network traversals. And I basically want to highlight how we can bring these 2 technologies together, graph and vector, all in one database and quite easily. So as I said earlier, when you have tables, if you try out this live lab, you'll see that when you have tables, it's easy to create a way to create a graph from those tables. So you take the data that you have in 3 tables, a customer table, movie table, and the fact that which customer watched which movie. You're taking that and then representing that as a graph. And I want to highlight here that the movie nodes here in this graph have various additional properties that are derived from the columns in these tables. And the key column here is the summary column that contains information about the movies, a description about the movies, and that's where we'll be using vector search. So you can see here that some customers have watched movie 1, some customers have watched 3 movies, some customers might have watched the same movie twice. So there are various movie watching patterns, and also which customers watch which movies together. We want to take that all and use graph queries to find out a good group of customers to watch a movie, and then make a recommendation by looking at the vector descriptions here, vector representation of the descriptions. So, and that's what we'll be combining vector search with graph search. So let's say I want to create a watch party. What movie should I choose? And which are the friends I should invite based on past movie watching history? So we just go through these steps one by one. One is I want to watch a movie, and that will be a pure vector search example. I just want to say, okay, I just want to go through these movies and find a movie that matches an adventure theme, because that's what I want to have a watch party for. And then I want to look at other watch parties I've had, because I want to invite the right set of friends. I don't want to just invite somebody who will be bored. So I want to invite the right set of friends based on previous movie watching histories, and that's where I'm going to kind of navigate my social network and then combine that with the vector search. So first here is a simple vector search. That's just a query, and this is in SQL. You could run this from, let's say you're having a Jupyter notebook, you can run this from Python using your Python drivers. But if you're using a SQL tool, you could use that, and it would look something like this. We're selecting all titles where the year of production was 2024, and where they have the theme is adventure. So you can see here we have this vector distance function that is integrated into SQL. So just like you say, select from this table where ID equals something, you can say select from this table where vector distance is something. In this case, we're ordering by vector distance. So it's really easy to include vector distance in any SQL query that you're running in an Oracle database. So let's see how we next do the next step, which is I want to identify the past movies that are similar to this movie. Once again, I'm using the vector distance function. I'm looking at all the movies that have been watched before. I had identified, after looking at the movie descriptions, I identified a particular movie, The Fall Guy, and I want to say, okay, which are all the previous movies that I've had watch parties for that where the movie is similar to The Fall Guy. And then you get to the graph part of the query, which is for these movies, for the who among my friends are likely to be interested in The Fall Guy based on previous movie watching habits. And this is the interesting query here is, so here I have the vector part of the query. So don't worry about the detailed syntax. When if you try the lab, you will see this, all these queries are in the lab. The key point is you can run a vector distance to find all movies similar to The Fall Guy. And then for all of those movies, you can find the customers who have watched that as part of a watch party. So this is the graph part of the query. And you can see here that the thing that you see with the match clause, that is how you're querying the graph, specifying a specific pattern, because graphs are all about connections and how entities are connected. So you want to say C1 customer connected to C2 is connected to your movies in the watch relationship. So you can have this graph pattern query to kind of navigate a social network of customers who watch different movies, and then use the vector search to match the descriptions of the movies with The Fall Guy to identify the right set of people to invite to this watch party. So the key point I want to drive home here is it's really easy to combine vector and graph search. And you can do more interesting things because graphs just bring a whole new dimension to what you're doing. So this, as part of the live lab, we have this where after you identify the list of people to invite, you can use the help of a GenAI service to send an invitation for this. So this is the live lab that we have. You can just go to livelab.oracle.com and search for GraphRag, and this will pop up right away. And all the queries I showed, all of that should be available. I'll go to example 2 now. And once again, I do encourage you to post your questions if something is not clear or something you don't understand why we're doing things a certain way. Please do post those questions. So example 2 is where we're going to go into the document search, which is often the example used for GraphRag. So we're searching documents. We want to answer some questions based on content in documents, and we can see how graphs can help that. So, and here is the reason why people want to do this is, and a lot of people are doing research on this because they feel that there's a benefit in using graphs in terms of accuracy. You can get more accurate results, reduce the errors that GenAI service can make, and more importantly, help you direct the search based on what your organization needs, because there will be some information that only your organization has and that you can capture succinctly. Even the complex relationships, you can capture that as a graph and then use that to kind of drive your search. So lots of research being done on all of these areas. So it's a hot topic. It's evolving every day. So let's see how we are using that in a simple example here, which once again, you can try out in a live lab. So what we're going to do here is take a simple detective story, a Sherlock Holmes story, where a particular jewel, the blue carbuncle, is stolen. And then it's found out, Sherlock Holmes finds out who the thief is. So if you want to take this story and just give it to, let's say, just want to use vector search to find the answer for this. What happens is typically your vector search is going to, what happened is document will be chunked, and each chunk would be represented by a vector, and that will be stored in the database. So when you ask the question, who stole the jewel, then that would be encoded into a vector, matched with the different vectors stored in the database. You get the top whatever K results, and then you can send that to the GenAI service, which will give you the answers back in a natural language form. So that is the typical RAG. So what happens, interestingly, when you do that in this kind of a detective story, and it's just the detective story is helpful to illustrate where graphs can really add value. So because it's a detective story, right at the beginning, there is a red herring. There's a line which says, oh, John Horner, he's a plumber, was arrested because he was suspected of being the thief. And that's a deliberate line that's put in there to make the readers think that, oh, okay, maybe he is the thief, or so on, to deflect your attention away from the real culprit. So vector search just matches that right away, right? Because it looks at those sentences, it says, oh, John Horner, this is a sentence which matches, which could be an answer to who stole the jewel. So I'm just going to retrieve this as an answer, and this is what I'm going to return. But this is not the right result. So what happens is, if you, in addition to chunking the document, if you're also able to extract the relationships, entities and relationships from the document and represent that as a graph, you can then have additional context. So instead of just discrete or individual chunks from the text, you can have a graph that connects entities across chunks. And by connecting entities across chunks, you can arrive at the right answer. Because if you keep reading the story, nowhere does it actually say John Ryder, who's the real culprit, is the thief. It doesn't actually say so in so many words. It's implied with a lot of context. A human reader immediately gets it. So if you want to provide that context, so the context of who's connected to what across chunks is equally important, is as important as the chunks. That's the part. And I'm not saying a GenAI service can't do it. Something which can take in the whole story can probably give you the answer. But the point is, when something is not explicit, the graph relationships can help you kind of uncover the result. So what happens here is, when we do that, we have graphs. We take the story, we chunk it. We also extract entities and relationships using the GenAI service to extract entities and relationships from the same document, which is then stored as a graph, which you then use to enhance the context. And when we do that, when you have this graph, you can then have these entities that you see here, that the jewel robbery was located in the Hotel Cosmopolitan. Ryder is employed by the Hotel Cosmopolitan. The Hotel Cosmopolitan matches the Hotel Cosmopolitan. This is the connection of entities across chunks. And then Ryder rifled the jewel case. You can see that Ryder could be connected across chunks. So by looking at all of this information, you can more quickly see that James Ryder was the thief. And let me just show a very quick demo. So let me, okay. I'm just going to forward a few seconds. I think we just need to start from here. Okay. So here I have this, I am now using the Generative AI service to extract entities and relationships from this document, like the fact that Sherlock Holmes was sitting in a chair, or Sherlock Holmes talked to so-and-so, or Ryder worked with the Hotel Cosmopolitan. That information that represents this document as a graph, I'm getting from the GenAI service itself. So once the GenAI service returns information, it returns information in the form of entity 1, which is the head, entity 2, which is the tail, and the relationship between them. And it just gives me a series of triples, entities connected by relationship. And all of this, by the way, is autonomous, Oracle Autonomous Database UI. So in the lab, you'll be able to do this exact thing. So you see here the Holmes interacts with Peterson, Holmes interacts with Sherlock Holmes, so that you have to do a deduplication that Holmes and Sherlock Holmes are the same person. James works for Hotel Cosmopolitan. James Ryder showed something to the Countess, and so on. So you get all of these relationships extracted by GenAI service. And I'm using this statement. I told you about creating a graph. I'm using this statement to now create a graph from this information that's now stored in a table. So I extracted the entities and relationships. I created a graph. And now I can start asking the questions. I can say, okay, who stole the jewel? And it's going to use it can use the graph as well to help when it runs the query to help me understand the question. And we'll see that how it looks in a graph context right here. So this is, by the way, again, a Graph Studio notebook part of the database. So let's just look at a few simple graph queries. I'm just finding anything that's related to anything else. And this can be seen as, you can think of this as a graph representation of your document, like what's connected to what, and Sherlock Holmes is connected to a lot of entities, so that's what we were seeing there. And now I want to extend that query to say, okay, I'm looking for specific entities like the jewel robbery and the Hotel Cosmopolitan. I want to see who's connected to those entities because I'm looking for who stole the jewel. So that's important. And then when I do that, I can see here, okay, the Hotel Cosmopolitan is connected to the Countess who owns the jewel and who was staying there. It also has a lot of connections to James Ryder and some connections to the jewel as far as the story was analyzed. And now I can say, okay, now I want to, this James Ryder, because it's connected to Hotel Cosmopolitan, I'm going to use human inquiry and find everything that's all entities that are connected to James Ryder, and I find a lot of entities connected to James Ryder. He has spoken to the Countess, he had raised an alarm, he was seen rifling the jewel case, and all of these things. The story has James Ryder referred to multiple times in terms of all the things he was doing in the story. Though it never said James Ryder is the thief, but all of these connections are in the story. So you can see here that now when I just look at, I do a simpler graph query, I just say James Ryder and everything that is connected to, I'll find a whole bunch of things connected to him. And then I can now come back and I'll say John Horner, who's a wrongly accused person. When I query things connected to him, there are only 3 things connected to him. So though there's a sentence that John Horner was accused of this, in the actual story, only 3 things are connected to him, whereas James Ryder is connected to many more things and many more relevant things for the theft. So that kind of really highlights the value that graphs bring by highlighting how things are connected. And so just relying on the black box of vector search. So finally, this query, I'm just now finding everything, all entities reachable from the blue carbuncle. And you can see again represents the story nicely. You have Holmes at the center of things, Sherlock Holmes, and the blue carbuncle, and everything else is connected to Sherlock Holmes. The blue carbuncle is referred to as 12 and other things as well. So that's why you're not seeing that many links to that. So I hope this gave you an idea of how exactly graphs can really add value in terms of understanding what's going on in a piece of text. And we have a lab for the example I was showing. We have a live lab for that, which I encourage you to go and try. So with that, let me switch over to hand this to Rahul so he can talk about something exciting that he's been working on. Let's figure out how to stop sharing. Here we go.
Awesome. Thanks, Melly. Let me go ahead and share my screen. So Melly just ran through a couple examples of how you can use GraphRag. I'll walk through one more example. And so this is going to be using Python. So kind of to set the stage, there are really a couple different ways you can create a graph. But if we kind of distill it down to, oh, did my screen share stop?
Yeah, I stopped. I guess I don't know why.
Yeah, it's happened yesterday too. Why that happens. So when you create a graph, like Melly said, a graph is a representation of information stored as entities and relationships. But if you break it down into its simplest form, a lot of the time that looks like a sentence structure, right? So here we can see, I live in Denver, which is located in Colorado. Denver has an office at Oracle. I work at the Oracle office, right? So when we do that, not only does that give us additional context, but it also lends itself very well to extracting information from documents. So we really have 2 ways that we can extract entities from documents. One is to create a domain graph, which is where we extract the individual entities and relationships themselves. And the other is through what we would call a lexical graph, by chunking the document itself and extracting those facts from each chunk and linking those facts to those chunks, right? So the example of that Sherlock Holmes story that Melly just showed is an example of a lexical graph. And what I'm going to show now is more of a domain graph. So before we get into that, one of the benefits of using graphs for RAG is explainability. So because a graph query is an explicit representation of relationships, it can take some of the semantics into account to make the search based on graph retrieval, right? So we can retrieve some of that additional context instead of kind of being siloed into a more opaque structure that you would get from a vector search, right? So instead of kind of just representing, different information through these long vectors and running a similarity search, we can extract all of the relevant data that we might need based on the semantics of the question at hand, right? And so with that, I will head straight into this demo. So what I've done here is I've created a little Python sample demo where we extract entities from a document or from text, convert it into a graph, and then I've created a natural language interface so that we can ask questions about our graph. It will create our graph query for us and give us an answer back in natural language. So to do that, because I'm creating this as a domain graph, we can actually take vector completely out of the equation in this case. So to create this demo, what I did is I use the LangChain LLM graph transformer, as well as the Oracle DB library to store those extracted entities into my Oracle database. And then from there, just create that application to query the graph. So the first thing that I'll do is instantiate my graph transformer using some LLM. In this case, I've used OpenAI, ChatGPT, but you can use any LLM that's supported by this LangChain graph transformer. I have my text. So this is Albert Einstein's Wikipedia page. And then from there, I just extract those entities and convert our graph or convert our document into a graph. And once we've done that, we can just create our graph. And so in this case, what I've done is I've created two tables, one for my vertices and one for my edges. When I do that, I have my ID, the label, as well as our source and destination IDs for those edges. And then the last thing that I'll do is just write our create property graph statement. So our create property graph statement just says, these are our vertices or through our vertex table. These are our edges through our edge table. And then these are our keys that reference our vertices, right? And so once we do that, we can execute this against the database to create our graph. And then lastly is when we run this graph transformer, it comes back in a format that has a little bit of extra stuff that we don't really need. So I'll just use a couple regex expressions to extract only what we need from that LLM transformer and upload it into our database. And so once we've done that, we have our graph that's extracted from text, and then we can create our application. So in this case, what I've done is I've made a very simple Streamlit application using that Oracle DB library to query from our database, and then using the Oracle Generative AI service to interact with our LLM. In this case, for creating the graph queries, I'm using Grok 3. Other LLMs seem to do just fine, provided that you work with sufficient prompting. So in this case, I've created a system prompt that outlines what our create property graph statement was, a little bit of extra context about our graph, and an example of what the create property graph statement looks like. And then I also have the user prompt that we're going to use that comes in from our application to just pass that to the LLM and saying, hey, based on our graph, write a query that will answer the question at hand. And then it will take that query, run it against our graph, retrieve all of the relevant data, and then toss it back to the LLM to get our answer back in natural language, right? And so to show you what that looks like, my screen stopped sharing again. So to show you what that looks like, I can just go here, I'll run my application, and it will pull up over here. So this is what my application looks like. And again, this is based off of that Albert Einstein's text. So I can ask any number of questions about anything relevant to that document. So in this case, I'm going to ask, what awards did Einstein win? And when I run that, we'll see that it generates our graph query using that 2023 SQL standard. It will then query the results from our database, and it will generate an LLM generated answer, right? So we can see both in terms of explainability, we can backtrace on what our query was and how we got to our answer. We can see our raw results, and then we can also see our LLM generated answer. And we can do this for any number of questions, such as what are Einstein's achievements? And when we run that, we'll be able to get, even more results. So in this case, the LLM can extract from what we used in the system prompt to know that, the labels that we need are developed, contributed to, received, and discovered. As those contribute to what he might have achieved, we can get our raw results. As we can see here, it kind of looks like that sentence structure that I was talking about earlier, where Albert Einstein developed the theory of relativity. And then lastly, we can get all of that back in natural language directly from our LLM. So as you can see, it can be very simple to not only create a graph, but also extract those entities from text to create a domain graph to, answer any questions that you might have directly from natural language. Okay. With that, I will stop sharing and hand it back over to you, Melly.
Thank you, Rahul. So let me share my screen again here. So, so basically, just to kind of conclude here, this graph feature in the database is available in all editions of Oracle database. The free version, you have the autonomous database free, or you have a Docker image, anything you want to use, it should be available on the cloud, on premises, on your laptop. So graph is available everywhere, so you can play with it and do all kinds of interesting things with it. And just the key takeaways are that graphs provide a natural way to model real world data. Like you can take sentences and represent that as a graph. It gives you a way to provide enhanced context to GenAI, just direct the search of GenAI in a certain way. So, and to get to the live labs, any graph related live lab, just go to livelabs.oracle.com and search for graph. You'll find a bunch of live labs that you can, and includes the couple we were talking today. And someone asked me for the code that Rahul is showed. He's working on that right now, so it's available. We'll make it available. It's not fully complete yet, but we do want to put out examples in that context. So here are some more examples of live labs. And I think here are other resources for graph. We have our page, we have live labs, we have blogs, we have a YouTube channel. And here are some resources that I think Nikki had shared earlier as well for getting started. So with that, I think Rahul, there's a question for you in chat. Maybe you can answer that live since we're done with the session.
Yeah, so I think one of the questions was, how many rows do you have in the entities database? So this is a relatively small example. It's around 100 nodes and roughly 100 edges. So relatively small example, but it seems to, scale rather well. Are graph neural networks used in querying, or are they different? So a graph neural network is a little bit different. We do have some customers who are using, the graph database as the engine for a GNN. Melly, I don't know if you have any other thoughts on that.
Yeah, people are using graph neural networks, not so much maybe for search, but to find patterns and to basically saying, I'm looking for a specific pattern in the graph. I don't know what the pattern looks like, but I want to figure out which patterns exist in the graph when it comes to like looking for specific fraudulent transactions and so on. And their GNN is really useful. How do you handle loops? That's an interesting question. Maybe I'll take a stab at it and then you can follow up. So I think you're asking about loops in the sense that if Einstein proposed the theory of relativity, then it comes back to Einstein, right? I think that's the question. So right now in all our queries, I think we have bounded the query itself. we say, okay, find me all entities that are 1 hop away, 2 hops away, 3 hops away. At least that's what we're doing in my example. So Rahul, maybe you can comment more on that.
Yeah. So in my example, there aren't really that many use cases where it needs to traverse too many hops. So it's a very similar case as Melly, where it's kind of bounded. But one way of handling loops, if you do have a data set where you do need to do a large number of hops, is to use a distinct clause potentially, so that you only get the distinct edges, so it doesn't kind of transfer over itself. There's also a question in the Einstein example: how do we generate the domain graph? Was it made using LangChain's LLM graph transformer? Yes, it's using LangChain's LLM graph transformer with OpenAI as the LLM that I used. I also see a question that which is the website. I think, Guan, you're referring to Live Labs. That's just livelabs.oracle.com. Or if you're referring to the website for the Einstein example, that will be on GitHub, and I'll also make that into a blog post. We keep an up-to-date blog post called the Oracle Graph Learning Path, and I'll put that link in chat as well.
Yeah, and Rahul's code is not yet available, but we will, once we're completed it and polished it, we will make it available. You can post our GitHub link also, I suppose.
Oh, yeah, I could do that.
That's where the code will live, I think. I'm sure. The AI-friendly database. Is that what you're asking, Sainath? Are we providing the AI-friendly database? Absolutely. Database has a lot of data, a lot of really critically important data. Data enriches AI, as we know. So it is very important to our customers, our current customers and new customers, future customers, to ensure that our database is as AI-friendly as possible, as you put it. So we just talked about the graph part. There are various other sessions in this series which have talked about other features that are focused on making our database AI-friendly. And that's what AI World is all about. So in the previous slide, I had, I think, AI World here. So please do join us there. Rahul will be there. I will be there. Other colleagues will be there. Please do join us if you can. How different is it from other major databases? The key point is the comprehensive support we have for different data types and the converged database, right? So we have vector search, graph search in the same database, which also some others have, but we also have location information. Like Rahul has done some work on combining location data with graph data. We have JSON data. So all these different data types in the same database. So any data type you need, you can have that. You're right, the other databases might also use graphs, but we believe our support, first of all, is standards-based and can be linked with many other different data types. And all of this is built on the tried and tested and very mature database offering. The Oracle database has been around for decades, literally. So it performs well, it scales well, it's very robust. As someone once said, the server never really stops, it keeps going. You don't have to worry about server crashes. It's just a very robust database. And you can now use it as a development platform for doing these kinds of applications and so much more. But other databases, they're very niche databases too, right? They only do graph, or they do graph and back to one other thing. I don't know of any other product that's comprehensive support for all of these different data types that can be used together. Well, thank you for all the questions. It's great to have an interactive session. So We still have a few more minutes, so any more questions, please?
Yes, we still have a few more minutes. Feel free to post your questions in the chat. And also, if you prefer to speak to ask questions, you can raise a hand, and I can unmute you to have you can speak to ask questions or have an open discussion.
Also, if you want to try everything Melly and Rahul showed us earlier, you can sign up for an OCI account and you can spin things up on the account for free. And today, if you sign up using our link, you get $300 free cloud credit. And if you can share the screenshot in our Discord channel, you'll be entered for a chance to win some swag from AI Camp.
There's a question, do you recommend a book on GraphRag? That's a good question. I don't know whether there are any books yet, but there's a lot of material on the web in terms of blog posts and so on. Actually, much more from other vendors maybe than from us. We're just putting out some more stuff. Our live labs are the best resource right now. We have annotations in between, but that's an interesting point. I think we should maybe have like a tutorial that starts from the basics, which kind of will function like a book. Well, thank you.
So I think we have last questions from Mario.
Yep, I see that. Is Oracle offering its own parser for documents to extract the graph, or is LLM graph transformer the way to go? So for right now, I would say that the LLM graph transformer is one of the better ways to go. We do have plans to offer our own parser for documents, but that is not currently available.
That being said, I will say that Oracle text can do some amount of parsing. I mean, there are lots of other components in Oracle that can do some amount of parsing, maybe not to the extent yet of creating the full graph. That's on a roadmap, like Rahul said. But there are other pieces, bits and pieces here and there that we're bringing together. And thank you. That was an interesting book that you pointed us to.